Hello, good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning. All right. Um, so, good morning once again, everyone. I think it's a good time. Let's get started with our lecture for today. But before I begin on our lecture, there are a couple of things that I would like to announce. So, I think Ravi is asking, may I know if there are any PPT slides for the last two sessions, as I can see only 5 slides being uploaded so far. So, Ravi, I just wanted to answer to you that our sixth session was the hands-on session where we demonstrated everything about like the Kubernetes and the cloud AKS, right? And we also saw the Docker in the last lecture. With regards to the last lecture, yes, I would upload it because this is a post midsem thing. So that's why I didn't want you to confuse the midsem makeup paper exam candidates. Therefore, I didn't upload it, but we covered in the last to last lecture. Okay. So last lecture, I think it was your makeup examination for the midsem. So that's the reason that you do not see the last to last lecture because I didn't want you to confuse to the people who are attempting to the midsem makeup paper because whatever we covered in the last to last lecture was supposedly to be covered for the end sem for examination. Okay, I hope that answers. Number two question is also, can you please help getting lab access or please guide us if there is another way to access them as I've not got an email with respect to this so far. So I think there are two things. Number first is yeah, I appreciate your following up and many of them are following up. So I would like to update that there is a good news that your labs has been initiated in and reinstated. So all of you now can access to the labs, but nevertheless, I already announced in my previous lectures that you can create an a student account or you can create a free tier account at wherever like you like. For example, at Amazon AWS or at Azure, and you can start your hands-on practices as I've been um, doing into the class lectures. So, so I think there are both the options are there in the front of you. But now I think you already have the lab access ready and working. So please feel free to use it. If anybody of you is not able to really use that, then please do let me know. So we have the OSHA portal, and OSHA portal, we have EC2, S3, directory service, code pipeline, code commit, code build, right? All of that, Amplify, Dynamo, Lambda, EMR, API gateway, Kinesis. So I think a lot of instance connect, a lot of services that we have got in, uh, you know, uh, got established at the cloud. So please feel free to use it. And we also have the various other security related services like X-ray, API gateway. So all of them have been activated in your OSHA portal account. Inspector, guard duty, shield. So you name it, and I think you would find it. So there are a lot of things that we have, um, done over the same. I hope that answers. Do anybody have any questions on the labs? Please feel free to ask me.
Yeah, I think, sir, I uh, the last I think the lecture that you have given, I think in the slide that you have shown a glimpse of assignments. I think the details will be soon uploading, right?
No, there are actually, yeah, I will upload the details. You're right, but there is nothing more than what I announced. So it's just that you guys have to start working upon first part is the test bed and second part is the hands-on demo. So you have to tell me what is the topic that you're picking up for the test bed, and you have to tell me what is the hands-on project that you are starting to build. I already
Okay,
gave an
that we
example
can choose. I mean,
that you can
okay,
choose.
okay,
Yes. No, there is nothing
okay, sir.
that I don't want to
Okay,
do
sir.
that choice for myself. Whatever you like. For
Okay, sir.
example, you want to build an home automation system using the cloud. You
Mhm.
want to do into some core engineering area. You want to build something like, for example, the face detection algorithm, whatever. Like just there are so many examples as of today. You can use that.
Yeah, sir. For labs, we can take some time, right? I mean, there is no, I mean, hard deadline, right? As of now.
Yes, yes, of course. That is
Okay.
at your own wish. You can try that out and you can use it whenever you want to do that.
Yeah.
Okay. I also see that there is a question from Mr. Avinash Narwade. Can you share the quiz mark? It is not uploaded yet to be. Hey, Avinash, we do not have the control over the quiz marks. I only can open the quiz and set the close timings. And I also specified that which option is correct. Now, how many marks that you got is something auto thing. I can share the question answers. I mean to say, I can share what are the right answers of that questions, and you can yourself know that okay, how many you got it right. If that really helps. But the quiz mark sharing is not in my control. That happens automatically from the system, from the Moodle portal side, which is Taxila portal that we have, right? So the people would make it out as soon as they find it the right time. They do have the academic, curriculum as well as, sorry, academic schedule basically. So they do refer to their schedule when they have to make the marks out for the entire EC2 and etc. And I think then at that time you would be able to see that. Okay. So I think I answered this question. Um, I'm just typing it for myself so that next class I don't forget about it. Okay. Just what's it not submit. Okay, the next thing is, can you please upload the lab assignment? I will do that, Gautam, as I discussed. All right. Good. Thank you. Fine. So please confirm if all of you are able to see my deck for today. Okay, nice. Thank you. Okay, fine. So Ravi is asking for total how many sessions? I think total we have around 16 sessions, but we will see 14 to 16 sessions is like something that we have. We will see. But any reason that you are asking about this, Ravi? I think we discussed this in the beginning of the lecture. Okay. All right. So let's begin. Is there any doubts, guys, before I begin on to the next lecture? Is there any doubt from the previous lecture? In the previous lecture, my dear students, we covered about the infrastructure as a storage service thing, and I'm going to upload the deck for that today because now the mid-sem papers are over. So we discussed upon the infrastructure as a service. We discussed about the three cloud computing models. We also saw that what are the various aspects related to the infrastructure as a service. And we also discussed upon the strategy, the tree, basically the binary tree type of structure to decide how to go for the infrastructure as a service or the platform as a service as a solution choice. And then we discussed upon, various categories of the AWS services. And we also saw about, how do you select a region, which region you go with, AWS region, meaning availability zone, data centers. And we also saw like a plethora of services which is available into the cloud. Along with that, we also saw the shared responsibility model of the cloud, where security is the shared principle. And then we also discussed about the IAM, which is a very important service, which is a global service. So if anybody of you have any doubts into that lecture, I'm happy to take that. I'll give maybe, please raise your hand, 5 seconds. If you have any questions or doubts from the previous lecture, you can ask. All right. So I believe that there are no doubts. Um, okay, fine. So Rosho, Pradeep have mentioned lab is open at the OSHA portal. I can see we got AWS access. Great. That is very nice to know that. Thank you, Suresho. Tanya, sir, will we get option on Taxila for groups members name submission? No, as I mentioned, you have to uh, maybe you have to create an Excel sheet, or maybe let me do like this. I'll float an Excel sheet link just after the class, and then you can mention your own names into that. Okay, I think that would be fine. All right. So cool. Let's get started with our today's lecture. So um, So guys, these are the services which are there when it comes to the category of the cloud computing services, okay, compute services. Now we have EC2, which basically talks about the virtual machines. Those providers instance basically based computer resources. What does it provides to us? It provides us good amount of customization for me to basically manage the virtual machines where I can pick up my own operating system. I can pick the type of the machine which I want to use, what kind of storage and volume that has to be attached to this kind of virtual machines, right? What kind of security that needs to be provided, who all can access. And so I have a good amount of control on the machines. Basically, when I say machine, my dear students, I talk about the virtual machines. So I have a good amount of control. Basically, I was telling the on the virtual machines which are getting created using this particular service, which is EC2. Okay. And now when it comes to the ease of use, most IT professionals, I think I'm talking about the pre-cloud era. So most IT professionals are aware of installing the operating system on the host machine. Okay. They're also aware about configuring that to join the specific cluster, right? They're also aware about how to make a machine join to its network. So those IT professionals were aware of with all of this concept. Okay. I mean, they have already done this all, so they were quite familiar with the EC2 concept, right? So this is the most popular and the first service from the Amazon Web Cloud. Now, when we moved on to the Lambda, this is a serverless computing. It does not mean that there would be no servers to run. Okay. It simply says that you do not have to manage those servers in order to run your code. This is what it says, right? What is that the developer has to do? The developer has to write his own code and deploy his code. How the scaling happens is managed by the AWS cloud. Since it is charged only when it runs, this is a very low cost solution. Okay, somebody triggers to run this particular code. Of course, you could schedule this code to run by itself at the different times of the day. Before the invent of the serverless computing, of course, the way we used to do was between so and so time, I don't have the usage and therefore let me stop my servers. So those kind of scripts were written over there. They were triggered, scheduled, and when they get triggered, they get charged. Now, when it comes to ease of use, the serverless computing is relatively a new concept. Okay. Earlier, they used to write the cron jobs, which were scheduled, but unlike that, this has more capabilities when it comes to execution of the code. Okay. So this supported the cloud native architecture better. Moving to the next one, that is umbrella of the containers. The container-based computing, which we usually call it as, so they help to run the multiple workloads in a single operating system. Now we have understood on what are the containers and how does the containers are run. So there is a host operating system and I can run thousands of the containers on the top of it without any problem. Okay. These containers seems to be the perfect fit when the application is being developed in the microservices architecture. Microservices based architecture says that you have a single module and it has a single responsibility. Okay. And it is basically ephemeral in nature. That is, it can die, but it would restart soon. Therefore, it needs to be resilient. So for those use cases of microservices, the containers are pretty good. Then the last use is Elastic Beanstalk. It is a quick way of deploying the web applications. This is seen as the platform as a service solution, and it provides access multiple access ways to various other services which are there as a part of AWS. For example, like DNS is there, database is there, right? Generally, these are certain things which are required for the web applications. Okay, so it provides provision to access them all as well. That is the beauty about all of these services. Is it okay? I hope you understood like the overall understanding of the compute services. Now, guys, we have seen multiple slides where we have seen AWS is offering many compute services. Now, in the previous slide, we also gave you a list of the services as well. Now, how do I make the selection from the pool of the services? How do I know which service shall be the most optimal compute service for me? And unfortunately, we do not have a formula for it. We do not have a one size fits, kind of a solution which solves this problem. So the final answer would be, it all depends upon the use case that you have. So based upon the use case, there are different types of services which are available out there, which would be used or customized as per the needs of the business. So what they tend to do is they have their application and then they know that, okay, um, basically there are various compute services which are available out there. So they deploy the application and then evaluate the performance. Basically, they collect the various metrics so as to what was the network IO, what was the CPU used, what kind of storage was used. So it's kind of simulating the environment basically. Okay. So you collect these matrices, then use the available elasticity because the application probably needs to be scaled up. So while scaling, what happens to the resources? How does it scales? You understand all those things, right? Based upon this particular input, you re-evaluate the computing needs. And basically with all of these matrices that you now have in place, you can reevaluate whatever like your needs were. Okay. Fundamentally, what is happening is that you need to start with using one type of service, okay? And then you understand the nitty-gritties of the compute services which are available. You see a possible change in the deployment or the virtual infrastructure which you want to use, okay? So it's kind of progresses in that particular fashion. Of course, there are certain things that you need to consider, like for example, the design of your application, usage pattern, configuration settings, which are required, and the things like that. But overall, like it basically progresses in the fashion that as I just described.
Okay. All right. Now moving on to the Cloud Compute, we're now getting into the very first service with respect to the details for the same. It is the very first service which comes, and it is the most preferred and mostly used service today. Okay. This helps us to set up our own virtual computing environment without the hassle of setting up our own servers. I hope all of you know by now this. We do not have to own or manage any servers here, and they are pretty much able to handle various traffic spikes which could be there, or the peak workload for that matter. Okay, I'm sure you must have read about the scenarios like, for example, like Book My Show and Flipkart.com when some huge famous events comes. For example, for the Book My Show when like Iron Man was released, then the ticket services stopped. Similarly, on the Flipkart, the Big Billion Day, the website almost stopped. In a very, very less time, the services came up also very soon, in a very short span of the time, right? Similarly, you might have observed earlier about the time when, a long time ago, when the results were used to be announced at the nic.in government websites. It could be CBSE results, or it could be IIT results, right? Earlier, they used to provision their own servers and they used to struggle to give your own result because of the heavy load on the system. Now, meanwhile, you get to know from one of your friend that, hey, their results are out and your results are not out, then of course, a little bit of, euphoria and attention builds, isn't it? So basically, they did had a notion of the capacity at that point in time also. That's what I'm trying to say. Which they had planned. But still, the things can go wrong. So ideally, at that time, they were unable to predict the peak workload which was expected. Okay, say suppose the website owners procures the required number of servers. Now, we also know that the results are not announced on a daily basis. So then what would happen to those servers on other days when the results are not announced? Of course, the servers would be underutilized on the other days. But still, how But still, what you would like is you would have to maintain those servers and then spend the money in maintaining those servers. So on your screens right now, there are various servers listed which could be installed on the EC2 instances or virtual machines as we call them. And the list is not limited to this. I'm sure most of you would be familiar with this different type of servers, and some of you might have used them at some point in time of your lives. So that is what like we have the plethora of the services. Now, adding to this, my dear students, EC2 also provides a resizable compute capacity with the help of the cloud. Okay, this is a high-level feature of the EC2 that we have as of today. Okay, so I hope you understand now that how does the Elastic Compute Cloud helps us to prevent from a situation where we would have to unnecessarily maintain some servers uh, in the case when they are really not getting used. So we can have the scalability kind of solution there. All right. Now moving on to the details of the EC2, it is named as Elastic Cloud Compute. Now, why Elastic? I'm sure by now all of you understand because they helps us not only in the scaling in or scaling out, but also helps us in scaling up and scaling down. Okay. So if I have a specific server, I can always try and choose another type of server which have better hardware specifications. On that enhanced server, I can host my application. I can scale down as well, but most preferred options would be scaling in or scaling out. This is also known as horizontal scaling, that is adding servers or reducing number of servers. Compute, obviously this is being used for compute purposes. Why is it called as cloud? Because the host servers runs in the cloud data center and hence the name is Elastic Cloud Compute or EC2. This provides us the option to us to have full control over the virtual machines. When I say full control, it means that starting from the operating system to the way that I configure it, who can access it. What is that this machine can access with respect to the other resources? Everything can be controlled by the user. Okay.
what kind of guest operating system should go on it. Whatever operating system is being installed on the virtual machines is called as the guest operating system. So it could be Windows or it could be Linux, or it could basically launch in any size or in any type or in any availability zone. Okay. The seed of this particular virtual machine is called as AMI, which is Amazon Machine Images. We would study about the AMI in a bit. Basically, it's nothing but it is a template which gives us enough information to start a virtual machine. Okay. And what do we expect? We have seen in the demos that in a few clicks, we have seen how the EC2 machine can be spawned from the AMI. Okay. Now you may be wondering that if we always have to perform these clicks in order to launch the EC2 machine from the AMI.
The EC2 machine from the AMI.
Hello. Uh, Guys, can you hear me well? Is my screen properly visible and am I audible?
Yes, 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 sir.
I see. Okay. All right. So I was explaining to that. I was explaining to you guys. Um, so what I was explaining is about the AMI. So AMI basically, I would explain about it. It is like nothing but it's a template. So what happens is that through a single line of code, you can launch a virtual machine on any number of virtual machines. Now, if I have to compare this with the containers, then of course there is a severe drawback here because they may take a few minutes in order to launch these virtual machines. Why? Because you have this elephant operating system to be installed on the virtual machine. And that's why it takes time. And then using the security groups, I can definitely control upon the traffic that has to come to it and the traffic that has to go out of this virtual machine. Okay. So that's about it. I hope you understand about all of this concept, guys. Is there any question? I'll take a quick pause to check if there are any doubts. Is there any question, guys? Is there any doubt that you have? Okay, tell me, are you able to understand? Are you able to follow what I'm trying to say?
Yes, sir.
Okay, great. Okay, I see there is a question. I see there is a question from Vineet Shah. He's saying what details info can be stored in the AMI? That's a very good question, actually, Vineet. So what happens is um, the AMI is basically a blueprint. Okay, understand it from that point of view. So imagine that you have to create an EC2 instance in the AWS. Okay, now it defines the AMI. Basically, what it does is it defines everything that the instance that your EC2 instance would need to start and run. Like, for example, the exact snapshot of an operating system, its configuration, right? Its application setup, whatever you need. So it contains the information about the operating system that you need to install, the launch permissions that you basically have. Basically, it controls which AWS accounts can use the AMI to launch the instances. It would then define how storage volumes are attached to the instance when it is launched. It would have the architecture. It would have the virtualization type. It would have like the configuration information, right? So now, if them simplify, if I have to simplify this, you can just simply say that, hey, in the AMI, you mention what is operating system like Ubuntu, Windows, Linux, etc. Then you also do in software and packages. For example, you gotta install Docker, Nginx, Node.js, whatever like the software that you need. Then you would specify the configurations, the permissions, etc., and then the storage configurations, etc. also. That's all that you specify into the AMI. So basically, you can consider AMI as a blueprint, right? Blueprint, like for example, if you have seen in a factory, right? So they can produce as many identical machines, as many as EC2 instances from that particular blueprint. It is like a class, and you can create n number of objects around it. So EC2, if I have to give you the analogy from the object-oriented systems, so AMI is a class, and EC2 machines are its objects. So सारे objects would be same, identical, correct? That is what Vineet, AMI contains. Is that answers your question? Is it okay?
Yes, sir. Yes, sir. Yeah, I got it. One more thing, sir, like suppose I have one like running instance of the EC2. Can I convert that running instance using my private AMI?
So you mean to say running instance of the EC2?
Correct. I need to convert to the image. Is it possible? My private somehow.
Very good. Yes. And that's exactly I'm going to talk about in the coming slides. Of course, you can create an AMI from a running EC2 instance. And actually, if I tell you, this is one of the most common DevOps practices in the AWS. So basically what happens is when you create an AMI from a running instance, basically you create an image from a running EC2 instance. AWS will take a snapshot of all the volumes that are attached to that instance, snapshot of the operating system, the configurations, etc. And then this snapshot is then used to build a reusable AMI for the future. And after the AMI is being built, later you can launch as many as new identical EC2 instances from the newly created AMI. Okay.
Okay. Is it okay? Thanks.
Yeah, it is possible. And there is a very good way. This is a very good use case. This is a very common practice actually. So using the AWS CLI, you can create that, or you can also do that via the dashboard also. Very possible.
Hello. Hello.
Yes. Hello.
Yeah, sir, I have a question here. So, let's say we have one server, EC2 server, and the server have attached 100 GB of volume, and we have taken AMI from
100 GB of
volume, EBS volume.
100 GB of
EBS volume, I'm saying volume
okay,
attached to.
ingress volume. Okay,
Oh, yeah,
ingress volume.
yeah. So, and the one of the application is running on the server. So we have taken AMI from the server. So, and the pros the AMI, we have, so this AMI is customized AMI because we have application is also installed on the server, and we have taken AMI from this uh, server. Let's say we have taken the AMI and launched the server in another region. So, the all the configuration will be come up in this server, those in the customized the server we have launched from customized AMI. But regarding the volume part, like so, let's say we have 50 GB is occupied out of 100 GB. So all this data will be come up with this AMI in it. So how it is that?
Uh, Very good question. Very good question, I think. So your question is whether the data that was earlier there in the ingress volume, which was attached to the EC2 from which we took the snapshot, would also come here, right?
Yeah, yes, sir.
So I think I would rather say this is a very good thought process, first of all, very good. So the answer to this question is, the short answer to this question is no. Why? I will explain it now. So whenever say suppose let's take an example. So for example, you have your EC2 instance running into the Mumbai region, okay? And say suppose you have 100 GB of EBS volume attached to this. Now it contains some of your data, and then all of your data is like around 50 GBs. Now you create an AMI, and now you go and launch your new instance from that AMI in some another region. Say suppose you want to launch now in the Singapore, okay? So what happens is, first of all, the concept that you have to understand is AMIs are region specific. Now, when you say create an AMI in the Mumbai region, it stays stored in the region's S3 backed AMI storage. So if you try to launch a new EC2 instance in the Singapore, then that region cannot directly access the Mumbai wala AMI or snapshot, right? Number first concept. Number two, in this case, what you would have to do is you would have to first copy the AMI to the target region. So you have to go to the EC2 AMIs and you can try that out in your OSHA portal. You would have to select the AMI and then you would have to choose actions basically to copy the AMI into the destination region. Now, concept number three, after you copy, what would happen internally? First of all, EC2 would register a new AMI in the destination region, which is your Singapore in this case. So you would see a new AMI in the Singapore EC2 AMIs, and it would also copy the EBS snapshot. Okay. So, what happens is the data that was there in your Mumbai region would now be copied from the EBS snapshot and it would be included into the new AMI that you have just created into the Singapore region. Okay. But after you have copied the AMI, it would bring both operating system as well as the data. Of course, please note that you would have the data transfer cost associated with it because you would have the storage cost associated in the Singapore region also. Okay, so that's the reason I mentioned. The short answer is no, because once you create the AMI, it will not be automatically copied. But long answer is yes. Why? Because you'd have to manually copy the AMI from the Mumbai region to the Singapore region. And in this process of copying the AMI from the source region to the destination region, your data along with the operating system would also be copied. Okay, is that answers your question, Mr. Sorosho?
Yes, yeah, I have some confusion here. So if I'm explicitly not taking a snapshot with this AMI, will be data included in this AMI, or we have to be included the snapshot with the AMI also in the process of creation of AMI?
So your question is, can I take so if I understand it, can I take the AMI without the data?
Yeah, without taking snapshot creation of AMI.
Fantastic question. First of all, I appreciate your thought process. And see, you have to understand when by default, when you create an AMI, it would by default and automatically include the full root volume. Okay, your operating system as well as everything that you have on that disk. But of course, the AWS provides you an option whether you can exclude or detach the data volumes. So if you do not want to copy the data into the AMI, of course, you can do that. And if you want to copy, of course, you can go with the default option. One thing that I would like to tell here is this is exactly what the need that we have to do when we think in the terms of the costing, in terms of the image size. Because if you have the image, because if you have the data copied, then your AMI size would be very high, would be very huge. Okay. So you can, of course, do that. Is it clear? Hello?
Yeah, yes, sir. Yeah, thank you.
Is it clear? Is it clear now?
Yeah, it is clear now. Yeah, thank you.
Okay. Um, Any other questions on the AMI, guys? Any other doubts you have? But very good discussion. I appreciate, like, I think these are very good concepts. We should definitely all right. I think okay. I think Yash also has a question. So why the reboot is required when the creating an EMI from an EC2 instance? Okay. Um, so let's go into the core reason first of all. Okay, so that I can explain it perfectly. So what happens is, Yash and everyone, when you create an AMI from a running EC2 instance, then hello, can you hear me? No.
Yes.
Yes, yes,
Okay.
sir.
Okay. So what happens is when you create an AMI from a running EC2 instance, AWS would basically need to make sure that the image that it is going to capture is in very consistent, it is very clean state. Okay, it just like it is taking a snapshot of a running computer. So if you do not reboot, you would might end up with having a situation where you might have some corrupted cache or the temporary files. So therefore, AWS would automatically reboot the instance to flush the data to the disk and guarantee that there is a consistency and integrity before taking the snapshot. So what happens is when you basically click upon, for everyone I'm telling, those who do not know about the process. So as soon as you click upon the create image button, AWS would start the AMI creation process for your EC2 instance, and AWS itself would initiate a short reboot if you didn't disable it. This reboot would make sure that all in-memory data which is written to the disk and all the handles are closed. Okay, so that basically the consistency is being basically obtained at that point in time, and then AWS would take a snapshot of that as DBS volumes uh, basically, and then the snapshots would form the basis of your new AMI that you are going to create. So now there is also an option I would also like to tell. There is this option to skip the instance reboot before you create an image. And if you check the skip instance reboot option, then AWS would not reboot your instance. AMI would still be created, but in that case, it is risky option because the data integrity and consistency is not guaranteed in that case. Okay. Does that answer your question, Ayush? Okay. All right. So can you all see my screen? Can I continue now? Is there any other question? Is everyone can see my screen right now? Okay.
Yes.
All right. Thank you. All right now. So guys, from here until next 9, 10 slides, we shall see various steps which are involved in creating a virtual machine. Okay. And I'm sure we have already gone through all of these steps multiple number of times. We have selected the AMI, selected the type of instance, configure the network settings. But using these slides, I want to provide the final level of the details on each one of these steps to all of you. Okay, because it is like going to be a refresher for many of them. So now when it comes to the launching of the EC2 instances, guys, it all starts with the AMI. That is the Amazon machine image. What is that AMI helps us with? It provides us with a template with the help of which we can launch the instance. Okay. And that is what basically we also need to understand is that there are different AMIs for the different types of the applications which can get launched in the different types of machines. Say, for example, mail server works best on the CentOS operating system. Then you can work with that. Next, you have a database server which works best on the Ubuntu, right? Next, you may have the IAS server which can run best on the Windows-based machine. So you can have that. You can have different AMIs, different applications which can be installed and the machines to start with. Okay. What information does AMI provide in order to launch an EC2 instance? First and foremost, it's a template for the root volume. What is a root volume? As I was just explaining some time ago, the root volume is one which contains the operating system plus everything which is being installed in the operating system. Okay. So it has a template with this root volume. So, so what does the EC2 do with this particular root volume? It copies this particular template, the template that has this root volume, to the root volume of this instance that you want to start. Okay, then it starts with that particular instance. So this is what it happens in the process. And of course, later on, it has to have the launch permissions. Of course, you can control the launch permissions using the AMI, specifying whether that particular user has enough permissions, authorization to create or use this virtual machine or instances. Whether he has the control to use that specific AMI, that can also be checked. Okay. So what we said is that EC2 copies the template to the root volume of the instance. But what is this root volume? Where is it coming from? This is coming from another service which is called as the EBS. Basically, it is a block device mapping that happens where the volume is attached to this instance. Okay. So there are various choices which are available. There are some quick start AMIs which are there. I can choose between a list of the Linux Windows, Linux, then maybe the Mac operating system to start the VMs, or maybe the Windows I can choose, or I can create my own AMIs. Or there might be some marketplace where AMIs are available which have some pre-configured templates. Okay. For example, Bitnami was a very popular marketplace some time ago. Basically, it has a good amount of images which had all of the images having the lamp. Lamp is a stack, Apache, MySQL, Python, Perl, AMP, etc. Right? Various variations of this. It had various types of pre-configured templates or AMIs which were the part of it. Okay. Or I could also have a community AMIs which are available out there. But you should be very careful while using these community AMIs because you do not know what has gone into that particular AMI, right? So if you're trying to use one of those AMIs, then you're trying basically at your own risk. Okay. Whereas in the case of the AMI from the marketplace, AWS would have gone through the templates to understand what exactly runs in them. Clear? Okay. So now to exactly see, as I was explaining just few minutes ago, what goes on during the creation of the AMI. Now, what is that we start with? I need to first choose an AMI. Using the AMI, I launch the instance. Okay. Before you do anything, the first thing that you have to do is you have to select the appropriate region because whatever service you shall launch, the same shall be launched in that region. Okay. You need to make a choice for that region. Next, you can either use any one of the started AMIs or you can have a customized AMI in order to launch an instance. So this is what it is precisely happening when it comes to your Cloud Lab. For example, for Network Fundamentals for Cloud Lab, whenever you click on the Start Lab, they have already pre-configured the AMIs and using those, they launch the EC2 instances and then you provide you the access. So that's the one way. The other way is you would perhaps want to know how it initially started. Now I'm using this customized image. Fine, but how did it initially started? It all initially started with a starter AMI, which did not had anything apart from the base operating system along with some necessary tooling. Okay. Using this, we launched an instance to which we called it as unmodified instance. Then they gave the access to this instance to all the faculty members to us. That is, then we give the requirement saying that these are various tools which needs to be installed and they installed these tools and finally provided us the machine so that we can experiment and see if everything is working properly or not. Okay, so that's what happens in the step number 2. What is the output? We get a modified instance. And once we confirm that everything is fine, what they did was they captured the new AMI, to which we called as a golden AMI. What exactly happens is that we first create the snapshot of this particular EC2 instance from this root volume along with its root volume, and then register it as the new AMI. So that what happens over here. In fact, you should also give it a try. So you should create a particular instance, then customize it by installing the additional softwares like Apache, Nginx, or maybe MySQL, whatever like you like. Then there is an option for you to go and create the AMIs from one of them. So you can create that new AMI. Next, using that new AMI at a later date, you can start off with another instance. And then this entire very same process would be happening. I can also copy this AMI to the other regions as I just explained to you some time ago, wherever it is needed. And I can basically start the virtual machine using this new AMI also. Okay, so there is a preamble to all of this, my dear students. What is that? That is import a virtual machine. Okay, so let me first, basically tell you. So what happened is in the initial days when we were like kind of um, uh, started with this particular cloud computing MTech program, we didn't had a sort of the lab environment for the students to work with. Okay, mostly it would be theory that was taught, and then later on, when most of the courses requires the lab, starting from the C programming or any other kind of lab work, we decided that we would start off with the lab. But how do we start? That time AWS was matured enough, but we didn't have access to this AWS. So we created a free AWS account with a credit card, but to use it, it was still was very tricky. So what I did was we created a virtual machine inside my virtual box, installed all the software over here and virtual box, and also so basically just for your information, I would like to tell you the virtual box also gives me an option to export the running virtual machine to an OVA file. Okay, so I exported this, and I later imported this virtual machine into the AWS. Then what happened was we created various different OVA images which cater to the various domains like networking domain, engineering domains, programming domains, core engineering, etc. So we created around 4 or 5 different OVA images and later we imported them into the AWS. Once the AWS was imported to the once the same image was imported to the AWS, it created my AMI. And we suggested the users to create free tier AWS accounts in AWS, and we listed this particular AMI in order for them to create a virtual machine instance and to use this lab. Now, of course, this was all heavily loaded, but it worked till a certain level. But we didn't get too much of the success into it because it involved too many steps into it. Okay, I would say that success rate was around like 30 to 40%. But I was appreciated because we did started from somewhere and we knew that we had capability of moving further. Now that thing gave us the light basically through the end of the tunnel, and we proceeded with that particular option. Now at the end of the day, it was not an easy process because many of the students gave up because there were a lot of steps that had to be performed. But there was a solution. We became a member institute of the AWS program. Earlier it was called as a AWS Educate, and using which basically they said that okay, each of the students would get around some free credit to work with various things, and then we started using that. So that's how basically the lab journey of the WILP division started basically. Now I think, but we are very much matured right now. We have multiple different labs rather. 3 labs, the primary labs that I have it for the network fundamentals, big data systems, and AWS cloud computing. And we also have a virtual lab uh, which is hosted on our Azure, which is coming soon. Uh, yeah, and we also have a hosted remote lab rather in our Hyderabad campus where we have 35 server grade machines. I think now the number is pretty high. I think now the number has gone to more than that. It has a lot of good amount of storage, compute power. They are used to host our compute intensive tasks like Spark, Hadoop, etc. And the recent addition to this is the cloud lab of the OSHA portal that gives us a full-fledged cloud experience compared to the previous steps. So hope that I'm not bugging you with my story, okay, of the lab's evolution. Okay. Uh, thank you. Okay, so now let us see what does EC2 has to offer to us. Now, as I said, one size doesn't fit all, and that's the reason. Depending upon the basically use case, I can create various types of instances. When I say various types of instances, that instance type helps me to choose with respect to the various combinations of the RAM, CPU, storage, along with the networking capabilities. And it also has a various categories. So if you remember that during our demo, we did choose the general purpose EC2 instance. There was an option for me to choose an instance from the various categories mentioned below. So this instance type gives me the option to choose an EC2 instance from the various families available, like various generations of the families, okay, like that. Now, what is this generation? What is this family? What is the size? Do anybody know about it? I hope some of you at least would know about it. Can you raise hands? How many of you know about all of this? Okay, nice. Okay. How many, can you please type in the chat window? How many of you do not know what is an, what is this basically family and size, etc.? Does everybody know about it? Just mention something in the chat. Yes, no, at least कुछ भी mention कर दो guys. Whatever you know or not don't know. Okay. Mm-hmm. No problem. So let's see about that. Okay. So guys, we have the T3.nano, T3.micro. Please understand it very well. T3.small, T3.medium, etc. These are all the names. They have certain conventions. What is that convention? Here T stands for the family name. That family could be either general purpose, compute, or memory optimized storage, isolated compute, any of it, etc. Then the three basically here is specific to the generation number. The generation number basically talks about the power. If you have a high generation number, the system usually is more powerful, and if you have better value for the price, which is a part of it. Okay. And the last thing is the large. This specifies to the size. Okay. So if you look into this particular example, we have T3 dot large. We also have T3 dot extra large. We also have T3 dot 2 extra large. Okay. If you see, these are all 1:2. For example, in the large, vCPUs are 2. In the extra large, vCPUs are 4. In the 2x large, the vCPUs are 8. Similarly, the RAM memory is 8, 16, 32 GBs of the RAM. So depending upon my requirement, I can go ahead and select the size of the instance. But another very important thing is that the network bandwidth is tied to the size of the EC2 instance type. Okay, depending upon the instance type that I'm choosing, network bandwidth to that particular instance is tied along with that. Okay, it means that I cannot assume anything. Why? Because since AWS has a large amount of bandwidth, everything can be provided to me. No, it is tied to the type of the instance. And as you can see, all of these instances are backed by the EBS for the storage purpose. Okay. Is it clear so far? Are there any doubts so far? Now everybody can respond. Maybe Gautam. Sorry, the people who responded no, like Varaprasad, Reddy, Jyoti, Meghna, Varun, Sardul, Yuvraj. Is it clear now? All right, so we'll take 2 minutes break and then we'll continue. All right. So let's get started again. Um, so I was telling that these are the various instance types which are available out there. Students, we have the general purpose, compute optimized, memory optimized, and accelerated computing, storage optimized, etc. Okay, basically general purpose is very good for the transactions and throughput. It is very good for basically hosting the websites and web applications. Having good repository is part of it, or having the testing and the staging environment is a part of it. Okay, it's named as the A1, M4, M5, D2, D3, like that. Okay, so all of this belongs to the same category, but M5 is better than M4. Similarly, D3 is better than D2. Okay, now when it comes to the compute optimized, it provides us high performance computing. Okay, it provides me instance which are compute optimized, and I can very well handle the load which is compute intensive, like weather prediction, scientific experimentation which needs to be done, or some kind of batch processing which needs to be done. That can be handled with these types of instances. Okay, the third one is memory optimized. Basically these instances are used for the databases which are in memory, basically in the nature. What is in memory type of databases? The database engine along with the data are present inside the memory. Now you may ask, otherwise is it not in memory? Here we are talking about the RAM, guys. Okay, in the RAM we have the data present along with the engine, and the transactions is happening in this engine are very fast as compared to the transactions happening where the data is being stored on the hard disk or the SSDs. The next one is accelerated computing, which is pretty much used for AI and ML kind of models that we have to run. Finally, we have storage optimized instances, which are named as a D2, H1, and I3, which provides a distributed file system kind of environment for us to work with. Okay, so this was about the instance types. Okay, so now let's move on to the third one where we have to do the network settings. Now, before doing any of the network settings, the very first thing that we have to do is the choice of the region, basically. Once the region is selected, the rest of it should follow. Okay, here it gives you the option to select the VPC. VPC basically talks about a virtual private cloud where we would like to create our own set of services to be the part of U2 access. So you can create a new VPC or you can go along with the default VPC. What does the default VPC does? Whenever you choose a default VPC, in order to create an instance, a default public IP is automatically provided to you. But if you create a non-default VPC on your own, then it provides you the option to select a public IP from the pool which you might have. So automatically when you create your own VPC, it does not itself provides any kind of public IP as such. Okay, public IP is only provided when you choose a default VPC. These details we didn't learn, we didn't saw in any of the demo so far. I just thought that I'm going to retain the default VPC and moving further when I launch the new new VM for my the demos that way we did. So if I would have selected some other VPC, then I would have to go and create my own public pool as well. Okay, so the question which needs to be asked here are like, what are the instance type that should be deployed? Should a public IP be automatically assigned? Then we have to answer them. So you can see here in the diagram, when creating the instance, we are in the AWS cloud, which has various regions, which in turn have multiple availability zones. Within that availability zone, we have multiple data centers. Although we don't go to that level, what is that I can do is I can create an instance by selecting that region. So if I create my own VPC, I need to have my own public subnet as well, which can provide a public IP to that instance. Okay. All right. So the next one that we choose is the IAM role. So now we usually selected the default IAM as well as when creating the user, but it is not advisable to do so when we have to select the default. Whenever we create an instance, it is always better to let it know what role it has to perform. Say for example, that particular machine is supposedly to access the S3 buckets, which has some objects, basically an object storage. So if I have an application which needs to access those objects present in the S3 bucket, then I need to provide a role. What is that I need to do in that case? I would create a role which will have a name. And I will make a selection, like for example, S3.read only. Excuse me. And then I would have to assign to that instance, isn't it? Okay. Once I create a role, it gives me a drop down from where I can pick this particular role. And while I create the instance, this role is pretty important. And once that is created, it provides the access to the S3 bucket along with that objects. Okay. And another best thing is, whichever instances are being having this particular role, they all follow the same policy. They all shall be administered by the same policy, right? When the role changes, for example, say along with the S3 access, we also provide the DynamoDB access of the table. Then it also applies to all the instances which have that policy associated with it. You don't have to individually change that instance for that. Okay. What is that I have done? I have created the instance so far. I have selected the role. And when I change the role, whichever instance I had that role, that change applies to all of the instances. Okay. Excuse me. Now next, coming to the user data, this step is of course optional, but it has a very good use case as well. Very good use case in terms of specifying that what you all want to patch your operating system. What is that you all want to update the operating system, or if you want to install the software licenses, keys from a license server, or install an additional software, then you can put it up in the user data. As you can see in the slide on your screen, what is that I have a small script which says that use the bash to run this particular set of commands. The first command is yum update. This is going to update this particular machine. Second command is yum install wget. This is used to install something from internet. Okay, so I can run this particular script or this set of commands which can be the part of the user data. So what happens is that when the instance is created, user data is run with the root privileges during the final stages of the boot sequencing. As a part of the user data, these set of instructions, instructions in the sense are the commands. They would be executed, and it is executed by a service called as the cloud init for the Linux-based systems. Likewise, there is another service for the Windows-based systems, but there you have to make sure that whatever script is that you write, they are compatible with that, with either the PowerShell or the admin console of the Windows. Okay. Now next option is, guys, we go on to specify the storage. Storage basically here means that we are providing a root volume. Okay. Initially, this is what we said. EC2 is going to copy the root volume, which has the operating system in the root volume of the instance. This is basically backed by the EBS. Fine. EBS is the one which provides us this volume or the storage for the operating system. Okay. So so this Amazon EC2 also has an instance store. Now please note that this is apart from the EBS. Okay. It also provides a block type of the storage, but this is temporary in the nature. Why is this temporary in the nature? This is because when the instance stops, the data is deleted from this particular store. That is EC2 instance store. But the same does not happen when the data is present into the EBS. If the volume is from EBS, then it is not going to delete that data. So generally what we do is we have this particular kind of particular instance store which provides temporary data in order to have some kind of cache. So whenever the instance reboots or stops and starts again, either because of some malfunction or willfully, then the instance store gets cleared and it starts again in a fresh manner. Okay. So for each storage, you have to specify the size and type as well. The types are two. One is SSD type and another one is HDD types. In that also, I can also make a specification on what kind of storage do you want to have, that we have seen earlier. There is also an option whether you would specify whether the volume needs is to be deleted when the instance is terminated, or what do you do. There are two things here. Whenever you delete that particular machine, you would want to delete that particular hardware. That is the storage which is associated to that particular machine. It is coming, if it is coming from the instance store, automatically it shall be deleted. But if it is coming from EBS, you would have to select that particular option for that volume to get deleted. But you can leave it unchecked as well, because it means that I can have the storage that is backed by EBS, and I can start an instance using that particular block storage also. Okay. Now, for example, say that we are running T2.micro type of instance, and I want to upgrade it to T3.medium or something, then I can retain the storage. Then what I can do? I can retain the storage as is, or I can delete the virtual machine and start a new one, new virtual machine with this particular storage. That is the same volume with a better logical hardware. Okay. Also, if you want to use the encryption, then you can use the encryption as well. It does not cost you anything extra. You can specify that whether you, it can specify whether you would want to data to be encrypted or not. You should try all of those things. I encourage you. Now you have your labs ready. So these are not very difficult things. Management console would give you all these steps in a very straightforward way. Now next, moving on to the tags. So let me just go to the tags. Yeah. What does the tags do? Basically, this is considered as a good practice. What it helps us with, it helps us to manage the resources so that it can easily search for them or filter them. I can create scripts using these names in order to send some events to the different other services. Okay, basically what happens is when we attach tags to the EC2 instances, it attaches the metadata to the EC2 instance. Now next, moving on to the security groups. We already understood the security groups. These basically provides a set of the firewall rules which is outside the guest operating system. It clearly specifies as in what port should be opened for this instance, what port should be denied for this instance. Not only for the ports, but also the protocols that should be supported and denied for this instance. All the instances by default, it provides such connections, incoming connection from the source. We can also specify the source. Source can be my IP, or it could be from anywhere, or it could be specific network where I'm present. Okay, I can specify any of it. So it will help restrict the access to this instance. Okay. Another interesting thing about a security group is that outbound traffic is open for all type of traffic. There are no restrictions. Okay, restrictions are there for the inbound traffic to this particular instance. This is something that of course you should keep a note of in your mind. Now coming to the last one where we have to create the key pair. Either we have to create a new key pair or use the existing key pair. Now using the existing key pair, I can have a very securely connect to my instance. In the key pair, there are two parts. One is the public key, which is being maintained by the AWS, and another one is the private key, which you would have to download while creating the fun. Or if you already have the fun private key, then you should select that particular key. Okay, kindly make sure that this is created using the management console. Okay, so there are two things over here. For Windows AMI, the private key can be used to obtain the administrator password. And using the RDP, we can obtain the access to this to these instance. For Linux-based AMI, the private key is used to make a connection with the instance using the simple tool called as putty. Okay, I can provide the private key, and using the private key, I can securely connect to the instances. Okay, so there are various steps which are involved in creating a virtual machine for the instance. Now, once this is done, you get this particular console which says that so and so instance type along with ID has been created along with all other details. Now, if you're wondering on whether this is the only way to create a virtual machine, it is not like that. You can, of course, create a virtual machine using the CLI interface as well. Of course, you would have to get yourself authenticated first by providing the access key ID along with the access key, so that when the user is greeted, he is provided with this information. That is the access key ID along with the access key. This information has to be stored and you have to authenticate yourself, saying that you are a valid user of a specific account in AWS in the console. That is through command line interface of your machine. Okay. And in one line, you can go about creating an instance. Obviously, I need to provide various informations that I selected in the various tabs which we saw in the previous case. But here in a single command, we can provide all of that information. We start the command with the AWS keyword and then EC2 specify the service which I want to make use of. I can manage and use other type of services as well. Okay, then the sub command for the EC2 is the run instances followed by the various parameters. What is the image that I have to use? I have to provide the ID to that. Every AMI would get an ID from AWS. That ID, whatever I'm choosing, I need to mention that here. From here, where would I get that ID? I need to look into the management console for that. Next subcommand which talks about is how many number of instances do we need to start with by having the option of the count. Count of 1 means we want to start a single virtual machine instance. Okay. Likewise, next one is the instance type and hence it is mentioned as c3.large. Next one is like the key pair that we need to supply with the help of which we shall be accessing this instance. Similarly, we should create the security group before we can use it here. And you have to choose the regions here as well. So my question to you all is, if I don't specify the region here, or if I do not specify the security group, then what shall happen here? Whether this command would run or not? Tell me everybody in the chat window, please.
I think so. The server will be created in default region, sir, with default security group.
Very nice answer, but I think you should respond in the chat, okay? Everybody else, do whatever you feel, please write down in the chat window. Yes, your answers are right. It is going to make use of the default regions which are there basically. It is going to make use of the default security groups which are there. So okay. So I initially mentioned about the default ones. So I think the ones which are default would shall be used in this particular use case also. Okay. All right. Here I didn't talk about the key pair, my dear students. There is no default key pair as such. Please note this. But there are definitely some default security groups and regions. I mean, you can also check on what would happen if we do not provide the instance type or what would happen if we do not provide the count. Okay. Of course, we need to provide the image ID. I do not think that they provide a default image ID. So maybe you can take this as one of the tasks for all of you to check and see what happens when you give your inputs without some of these crucial parameters and see what would happen. Guys, these are very, very small things, but interesting things would come out of it. Most of the times we shall have to ignore it. Probably some of you think that maybe it's my responsibility, but I feel that it's my duty to make you guys play with whatever resources that are available with us. Okay, only with that you're going to explore. Otherwise, you would have constrained yourself with whatever I'm teaching. All right, so this is the life cycle of the EC2 instances. So what do we do after selecting all those parameters or after initiating this command? It tries to launch the instance. It basically comes to the pending state before it goes to the running state. What happens here is that this virtual machine gets deployed onto a host, where a host is a physical server. Now, how will it get to choose a host? This is the question. On which particular host would this VM shall be running? How will that be chosen? I repeat, the question is, this particular instance is getting deployed onto a host. How would the host be selected for you to run this instance? I want answers from all of you in the chat window, please. Okay. Uh, do not unmute yourself and speak up because others are also responding. Is question clear? Okay, I repeat again. Whenever you launch a virtual machine, how the decision is taken that, okay, this will be deployed on a particular host. How the host would be selected for you to run the instance, to run the virtual machine instance? That is a question. Please respond in the chat windows. Okay, so all of you have responded based on the available in the host. Yeah, so you're right. So the selection is based upon on the instance type and that we talked about in the various instance types. Depending upon what instance type that we have selected, it would try and target to that specific host. By targeting host, I mean the category of the host that it is going to choose. Okay, now from the pending state, let's get back. So from the pending state, it would come into the running state. From running state, you can reboot the machine or the system can reboot itself because of some problem in the system itself. But if you're rebooting, then make sure that you are not rebooting this when you are within the guest operating system. So well, this is a very interesting situation. What would happen if you try to reboot actually? I repeat, all of you, please answer. So imagine I'm rebooting and then I'm within the guest operating system. What would happen if I try to reboot again? All of you, please answer. Please answer, everyone. No. What would happen is it would go into the zombie state, right? So therefore the suggestion is that you need to reboot it either using the console or using the CLI or using the SDK, but not by getting into the guest operating system. Okay, I was talking about the rebooting, guys. We can issue the reboot command from the instance as well, but it is not suggested to do the same because as soon as we issue the reboot command, we lose the connection as such. For another thing that we should note is that when the instance reboots, it is going to retain its host on which it was rebooted. It is going to retain its public IP which it was assigned earlier. It will also maintain the DNS which it was provided earlier along with the instance store volume. So we talked about the reboot. When we come to the stop state, say an instance goes from the running state to the stopped state, it goes via an intermediary stage known as the stopping, and finally it stops. When an instance stops, it has a different set of features. What is that? The public IP which was assigned to it shall change whenever the instance is stopped. The public IP shall be returned back to the resource pool. The instance store volume shall be deleted. Only if it has EBS, then that EBS shall be retained, and you can stop that instance if it is backed by the EBS. Okay? Now my question to you all is, if it is getting rebooted, then you get a public IP, whatever was there, you get the volume backup which as well. All those things shall be preserved. Now if you stop that instance, all of those things shall be deleted. Okay? Public IP would be no more, DNS no more. So these things changes. Why two different ways of handling these things? Answer me in the chat window, please. Why there are two different ways of handling? There is a stop that we discussed, and there is a rebooted that we discuss. And the behavior is different. In the rebooting case, you get the same public IP, same volume backups, everything would be preserved. In the stop instance, all things shall be deleted. Public IP no more, DNS no more. Why these two things changes in the and two different ways of handling? Everyone please participate and respond in the chat window. Good tries, guys. So let me answer this. So guys, there are two different ways of handling that we discussed. It is because in case of the stop, there is no guarantee that the VM will start immediately. Okay. There is no point in holding all of these resources. Okay. When it is in stop state, it is stopped as such for a specific reason. And it is very much expected that the instance shall be restarted, but it is not the same situation when it comes to the reboot state. With reboot command, whole life cycle would start again. That is, it has to stop and it has to restart. After the reboot, the instance is going to rerun again for sure. This thing we are sure. Okay, that time the resources shall not be returned back to the pool. It will get its public IP address, it will get its DNS, the thing shall be retained. When we stop, it stops billing. From my earlier experience, we had set up the cloud-based lab using the OpenStack, and it was in a very infant stage in those days. OpenStack was a kind of a white elephant. Okay, so we had one professor, I think Professor Dinkar, who has also authored one of the books also. He were aware of the AWS and he created an account in the AWS. And he also got some, more than 1,000 credits created for me. Now, after creating the account, he gave all the his account to all of his students, and he told that you know so better that you put the resources to the stopped state when you not needed it, because it may exhaust the credit at all once. Now in the stopped state, it would retain the data in the EBS and all, right? But if you terminate it, you would lose it. Okay. But that time, the option of whether to turning off the EBS when you turn off the instance was not there in the user interface. So the professor provided access to the students. Promptly, they used the various VMs of the various sizes. They judicially stopped the instances as well after their use. Now, after a month, there was a demo. After the first month, the professor got the bill of around 10,000 US dollar. On the second month, the bill was even more. He was wondering what is exactly happening. Then he asked me to look into the details of it. Then I had to connect to the customer care and understand the internals of what was happening. Then he explained, then these people, AWS people explained that for the stopped EC2 machines, they would also get charged. That's where we had to convert everything from the stopped state to the terminated state, retain the EBS, and then launch the new VB machines. Okay, fortunately, the professor, we was lucky enough to get the wave waiver from the AWS because they knew that it's all for the educational purpose. Of course, from the running state, you can terminate the instance and it goes by the shutting down state as the internal intermediate state before it gets terminated. As soon as the machine it gets terminated, it loses the public IP and it loses the EBS as well as, because if you have selected as termination, then it gets terminated along with the instances as well. Okay. So this is what I was talking about, guys. I'm going to skip this one and I move to the next slide. So now you have launched the instance. Now there are ways through which you can get the metadata information of the instances which you are running. Why is this important? There are instances where you write the scripts to get this information. Information like public IP, private IP, what is the host name of that machine, what is the security group. So you can extract all of this information with the help of the scripts and run the scripts to manage the applications and operating system settings. For that to happen, you should be inside the instance. Using the browser, you can use the URI as shown above, or using the curl as well. You can use the mentioned URL, okay? And whenever the user data which someone has provided, that information is something that you can get as well. Okay. So now I'm getting into the EC2 pricing models now. Most often when we make a selection of the instance type, it is for the on-demand instances. Neither there is any upfront cost for it, nor there is any long-term commitment for the same. And you can just pay for by hour basis. Also in your free tier, it says that every month for around 750 hours is something that you get for free. One particular machine that you can launch and keep it free and run it throughout, you would not be charged. But in your case, we have specified some credits and you need to work along with that. Again, whatever you shall be using would be on-demand instances, and they are good for short-term spiky and predictable workloads. These instances also participate in scaling and elasticity. The next option is the dedicated hosts. So dedicated host, it basically enables per socket, per core, per VM licenses. This is as good as owning that particular host, but it is being maintained by the AWS. Then there are dedicated instances. These runs basically in an VPC environment or an hardware which is dedicated for a single customer. Okay, so here there is physical isolation on that particular host level, that is host hardware level. This is the physical isolation. Then there are reserved instances and scheduled reserved instances. These are for the long-term commitments like 1 year or 2 year. The cost for this would be less than the on-demand because they are promising that they shall be customers for so and so duration. Okay. Beyond that, there are some support instances also. These are something which where users basically bid for unused instances and their costs actually fluctuates depending upon the supply and the demand. For example, there are some unused instances in the US East one, then you can use them because they are not used in the night time and for you it is the daytime. AWS also gives you a second billing for the on-demand instances as well. Also for the reserved and spot instances if you run the Ubuntu or the Linux and not for the others. So what is the benefit of the pricing models? On demand offers the low cost, but not that low as that of the reserved instances. But they give you very good flexibility to run your workload as such. Spot instances, you know your workload is dynamic in the nature, and you also bid for the kind of the workload that you want to run. Reserved, it offers predictability because you know what is needed now. Here you reserve the instances. Dedicated means it is very similar to the reserved one, but it is dedicated to the specific user. Okay. Here they would have to bring in their own licenses. It also helps to meet the regulatory and compliance requirements. And there are use cases as well which are present over here. On demand, short term, spiky, right? So on demand means it is like a short term spiky application development and it would need for the testing purpose. Spot means they're flexible. You know that you have a workload as basically which would have the start time and the end time with the application. And reserved basically means you know that you have a workload as such. Dedicated host means you basically it's where you bring your own license and comply with the policies. Right? Sometimes you may have the regulatory requirements. Then you have usage and licensing packagings as well. Now, this is a very important type of the pricing model because sometimes as a company you would have your own requirement for the licensing, etc. Like for example, if you're dealing into some specific industry, then you would have some your own needs for that. Okay. Okay. Now moving to the storage part. Of course, we have discussed about the storage earlier as well. But here we shall discuss about the EBS, S3 and EFS and the Glacier. Okay. All right. So guys, in the previous classes, okay, let me take a quick pause to check if there are any questions so far. Guys, please ask if there are any questions you have. You can raise your hands and speak up, or you can type in the chat window, whatever like you like.
Hello.
Yes, please.
Yeah. So, sir, the question is regarding when we are launching the server. So we'll be getting a network setting where we're not selecting anything like the network interface card. So I want to know. So what is the purpose of it? Why we are using that? So the IP address was will get based on the VPC and all the subnet we have selected, but the NIC part I don't know. So can you please explain that?
What is your question? In which context your question is?
So the question is like in the network setting. Yeah. So you explain the one slide.
Mhm, mm. This one, right?
Yeah. Yes.
Mm-hmm.
So the in the VPC and subnet we got the private IP address and the public IP address if we are selected like that, but the NIC the IP address also is also got to the server. So what is the purpose of that? That is my question.
The purpose of you are asking what is the purpose of a public IP address?
No, 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 not a public IP. The NIC network interface card.
Okay, so you're asking what is the purpose of NIC?
Yeah, yes, sir.
Very good question. So see, first of all, I will explain what is NIC. So NIC is nothing, but it is also called as Elastic Network Interface. Okay, network interface card basically in AWS. This is a virtual network adapter that is attached to your EC2 instance. You can consider it as like जैसे आप जो physical machines के case में you have the network port, so that connects to your physical machine. Similarly, you can consider NIC as your network port that would connect to your virtual machine to the AWS uh, cloud. Now, without an NIC, your EC2 instance has no IP address. It would have no network connectivity. It would have no way to communicate with any resources out there in the internet. So therefore, when you launch the EC2 instance in the network settings section, AWS would automatically create and attach an NIC. And it would, along with creating an ENI, which is NIC को ANI भी बोलते हैं. So it would also create the IP address. NIC would get one private IP address and one public IP address if you select one. Because private तो हमेशा मिलेगा ही मिलेगा. Public IP you get only if you select it. Then it would also connect to the subnet, which is VPC. The NIC connect your instance to a specific subnet. And then you attach it to the security group. And then NIC would work with the route table to determine how your traffic would flow out of the VM or in the VM. Basically, internet bound traffic, inbound traffic, or outbound traffic. So the point is, you would not be able to even define the allow inbound HTTP, SSH if you do not have an NIC. Is it clear?
Yeah, yes, sir. So it is a network layer, human right? So that will assign the private IP and public IP and the MAC address to the server. Is that clear? Correct understanding, sir?
So basically, what it does is it would, you can just understand, it would assign the IP. It would give the private IP and optionally the public IP to your virtual machine. And it would define that which network this instance would belong to.
Okay, okay. Yeah, got it, sir. No, yeah.
Okay, good. Any other doubt? Any other question? Guys, feel free to ask any questions, okay?
Hello, sir.
Yes.
If we select public IP address, then would pricing differ? Because it's something which we are reserving for ourselves, right?
Sorry, your question is about
Same
if we
slide. Yeah,
uh-huh.
if we choose to have a public IP address, would that have an impact on pricing? Is the question.
Of course, what do you think? So what is a public
Ye-
IP first of all?
Exactly. That's what I was. Yeah, because we are reserving some IP address for our host, it will be paid.
Yes,
We'll need to
exactly.
additionally pay for it. Okay.
You have a very good question, and I think this is a very important topic of discussion for the architects usually when they are into the parlance of the production systems.
Mhm.
See, let me explain it first of all. Okay,
Sure.
so there is a variation basically here. What happens is there are some public IPs which are ephemeral in their nature. Now, when I say ephemeral in nature, it basically means they can change basically. So there is an option in the EC2 that you choose, which is auto assign the public IP. Now, when you enable the auto assign public IP, AWS would give your instance a temporary public IP address. This public IP address is free of cost. Why? Because it changes every time whenever you stop and start the instance. This IP address would be released automatically when you terminate the instance. In this case, there is no additional charge. Now, there is another public IP also, which is called a static public IP. This is basically a reserved public IP address. It stays with your account until you release it yourself. And you can detach it to the different instances. It is good like for the stable endpoints. Okay. So therefore, the elastic IP, if you are taking an elastic IP attached to a running instance, it is it is free for only one instance, one per instance. But elastic IP not attached to any running instance, it would be charged, and it would be charged at an hourly rate. So therefore, the bottom line is if you reserve a elastic IP and then maybe you forgot to use it, then of course you would have to still pay host on an hourly basis. Because AWS is reserving a global public IP from its own pool for you.
Right. Right.
But if you choose just a auto-signed ephemeral public IP, which is not an elastic IP, then in that case, it is free of cost for you because it is temporary in nature, it is ephemeral in nature, it would be changed, it would be lost on the stop-start process. Very good question, by the way.
Yeah.
It's a very good practical question. And it is very much, I have seen this discussion for the architects and all a lot.
Right. Right. So public address is something which as in for inward interfaces, whichever organization has, those will need to have a static public IP address, so it doesn't change. So all the traffic gets routed correctly. What would be the need for temporary public IP, as in what use case we will require it for? Once traffic comes
See,
in, we can
see,
deal with
see, see,
private IP address, right?
so forget about temporary or the permanent public IP. A
Okay,
public IP is a public IP. A public IP is an IP which is reachable over the internet. It
correct.
basically allows your EC2 instance to communicate directly with your external clients. For example, there are some web browsers, some mobile applications, external APIs, etc.
Mm-hmm.
So imagine that you're hosting a public website. Okay. Now, if you
Mm-hmm.
deploy a web application, a web application server, for example, you have some REST APIs, you have some IoT gateway, etc. And then your users need to access this application over the internet. Then they
Mm.
must have a public IP or a domain map.
Correct, correct.
In that case, that is how basically you would need a public IP. So now, when you have a public IP, it does not mean it does not matter whether your public IP is a temporary public IP or it is a permanent public IP.
Mm-hmm.
Right? The public IP is a public IP. That is what I wanted to basically explain.
Okay, okay. Yeah, thanks.
Now, it may
So,
seem simple. Hmm, 1 second, let me complete my thought.
okay, sir.
So imagine that like if you have multiple EC2 instances powering to the application server, then it would have multiple public IPs, correct? Are you understanding it?
Yeah,
So then which one would your customers would use? That is a question now.
right. There should be a gateway concept, as in customers would be
Absolutely.
reaching to one guy and he would be passing on the traffic to others.
Yes. So imagine what I'm trying to
Mm.
say is that say suppose you have your web application
Mm-hmm.
hosted and you have multiple EC2 instances behind it running the same application, then each EC2 instance would get its own public IP if you enable it. Then if your customer
Mm-hmm.
accesses your application, then which public IP they would be using? Of course, they will not be able to possibly remember and connect to multiple
Correct.
IPs, right? So
Mm-hmm.
then in that
True.
case, the solution is you would have to use some DNS layer. You do
Yeah,
not expose the individual EC2 IPs to the customers. Instead, you put it behind a load balancer or you
load
put them
balance.
behind the DNS layer. So you put a single public entry point in the front of them, which is like usually the elastic load balancer in the AWS, which acts as a single
Mm.
endpoint for all the clients.
Yep,
It would
perfect.
automatically distribute incoming traffic across your various EC2 instances which are behind it. And usually the ELB also handles the health check. If one of your instance goes down, the traffic is routed only to the healthy ones. There is also something called as Route 53 DNS. For example, if you want a friendly name for your users, like a domain name to map to the load balancer's DNS name, then of course you can use the Route 53, which is global in the nature.
Right.
Okay, now continue to that. It may so happen, um, you know, uh, security wise, if you have the public IP, it does not mean that you know the public IP can be accessed openly by default. Okay, so there is a AWS security groups and NACLs that you can have, which can still control inbound and outbound traffic. So, for example, you can just open only required ports, like port number 22 and port number 443. So that is how basically um, you can just have the security also.
Right. Yeah. Thanks.
Yes, please. Next question.
Yes, so, sir, our web application is hosted on, let's say, like customer wise, we have about thousand of server. So, and the server was goes to the internet, like the traffic from server to internet. Like suppose we have to install some packages on the server, so we have to be assign the public IP to the server. So, is it necessary to assign public IP to each of the server, or we can
No.
uh, assign public IP to limited public IP. Like we have three public IP in different regions, and we have assigned this three public IP to the all thousand of server. It is possible. Like three IP can do the can assign to the all the servers. Like,
Very good
is it
question.
possible?
Very good. Very nice question. You have a very good question. If you have 1,000 servers powering to an application, and you have they're all sitting behind an elastic load balancer. In that case, you do not need to have any public IPs on those EC2 instances because they're only accessed by the load balancer. Because the load balancer is the public facing one. So in this case, your internet users would directly touch point with the load balancer only. And your load balancer would have the public IP and the DNS. Your clients will connect to the इलास्टिक लोड बैलेंसर्स पब्लिक आईपी जो पब्लिक आईपी इलास्टिक लोड बैलेंसर का है उसको क्लाइंट लोग कनेक्ट करेंगे डीएन या डीएनएस को कनेक्ट करेंगे ELB will then forward the request privately to the EC2s using the private IPs within the VPC. So therefore you do not need to have the public IPs. अब किस केस में पब्लिक आईपी चाहिए आपको? For example, you want for example, you want to administer, like for example, the SSH into the private EC2s, right? So then you can connect, if you want to connect via the bastion, then you would have to hop onto the private nodes. In that case, the public IP may still be needed. Or for example, if your private EC2 instances, they must use internet. For example, they want to download patches, they want to connect to some Plig APIs. Then they should be having the NAT gateway in the public internet. So that in that case, the public IP would still be needed. Is it clear?
Not actually, sir. So when the user want to come to the server, that will be goes to the load balancer. That is okay. But when the server want to go to the internet, like downloading some package and doing some curl and trying to access another application from one server to another server via the internet, then we have a lot of server, like thousand of servers. So we have to assign public IP to each of the server, or we can have a three public IP, or let's say three public IP in three region, and that can only be goes to the internet. Is that possible? Hey, good morning, everyone. Um, so welcome to class number 10 of our course.
I think your net text class have started already, but the short answer is no, you do not need. What I was explaining is uh, basically you would, if you want to use a NAT, then in that case, public IPs would be required. Okay, let's discuss that in the next lecture. Okay, I don't want to take a lot of your time for the
Okay,
next.
okay, sure, sir. Sure. Okay, sir. Yeah.
But very,
Thank
very
you.
good question. Please remind me about this in the next lecture. Okay.
Sure, sir. Sure, sir. Okay.
Thank you.
Thank you very much.
Thank you, sir.
Thank you. Thank you.